Okay, so for the video today, I want to talk a little bit. Well, so we're focusing on doing the addition method for our class, for our fraction class, and I want to think today a little bit about going from concrete to abstract. And this is a really important kind of concept. That's O should be down here. My thing always messes up. Concrete to abstract. It's really important for math and for computer science because computer science is so abstract. Everything we do is on the computer. You know, it's all these like little bits kind of running around in there. We can't see it. We have to kind of just trust that it's working the way that we think it's going to work. So in order to develop those kind of abstract ideas, those kind of formulas, those code, it's important to first start with some real numbers and then figure out, okay, how can we make this more abstract? And because our goal is going to be to write a code or figure out an algorithm where we can take any two fractions and add them together. And so what we talked about in class is, well, the safest way is just multiply both, on the left side, multiply both top and bottom by 3. And on the right side, multiply both top and bottom by 5. We'll get 3 over 15. We'll get 10 over 15. We add the tops together. We get 13. Keep the bottom as 15. And we get 15. Or 13 over 15. And this kind of algorithm of like multiplying the fraction on the left, multiply top and bottom by the denominator of the thing on the right, and then multiply the one on the right by the denominator of the thing on the left, is going to work no matter what. Even if our code was even if our fractions were really easy to add together, I mean, you could probably code this to where if we see these two things are the same, then just add the top. Or we could just take the same kind of blunt approach, multiply top and bottom by the bottom from the left, or from the bottom from the right, multiply the right by the bottom from the left, 2 over 2, and we get 2 over 4 plus 2 over 4. We get 4 over 4, and then actually we would just leave our answer like this. But we would know it'll be 1, but honestly we don't care if it's 1 over 1, if it's 4 over 4, like the answer is correct. We could simplify, but why bother? And this could work for anything, right? We could do 1 over 3. 1 over 6, like, again, yeah, okay, we could turn this into 2 over 6, but that's going to make more complicated code. Let's just make our lives easier. Multiply top and bottom by 6, multiply top and bottom by 3, we'll get 6 over 18, we'll get 3 over 18, add top and bottom, 9 over 18, and we could simplify later if we want, or just leave it like that, who cares? So now what we can do is, we've seen that this is going to work no matter what, whether it's kind of more complicated fraction like we started with, or kind of middle, or easy, or a little medium, I guess. The same thing is going to work no matter what. A over B plus C over D. How can we turn this? How can we get a resulting fraction where there's like no two separate fractions, just one fraction together? Well, we multiply top and bottom by D, right? Whatever's on the left side here. We multiply on this right side. We multiply top and bottom by B. We get AD plus BC all over DB, and that's a fraction. So all we really need to do in our code, so if I want to go back to this original one, and I wanted to just code directly and get the answer, I'd say, well, okay, this is A, B, C, D. Okay, so wherever I see A in here, I'm going to replace it with the A from there. So we'll get 1 times D, D was 3, plus B, B was 5, times C, C is 2, all divided by, let's see, what do we have, 5 on the bottom, times D on the bottom on the left side, 3. So we get 3 plus 10 over 15 is 13 over 15. Boom. So we could do this with our code. Like, in our code, when we do our addition, I was thinking of a much more complicated way of doing this and going through all these steps, but like, why don't we just go right to the equation? This produces an equation directly. So all we would really need to do in our class, and let me drag this down a little, just drag this up. So what we could do in our class is, like, if we have f1, that's some fraction, and we want to add f2, and we're going to get a resulting f3 fraction, we would need to do public. So we'd make a method in our class. We'd say public. We're going to return a fraction as a result. We're going to do addition. We'll take in a fraction called a, and I'm going to make a fraction called temp to begin with. Just kind of like, temp is a good word just for like, it's a placeholder, it only exists within this code, it's going to do a task, and then it'll get deleted. New fraction. So I could start with like just making a new fraction where these two values are 1 and 1, and at the very end of my code, I'm going to return that fraction back to the user. So that way, like, yeah, I'm going to add f2 to f1. f2 is going to be this fraction in here. We have access, because we're running this method add on this object F1. We have access to all of F1's method and all of F1's data, so we can mess around with F1's data. We already know its numerator, for example. We know its denominator. We have access to all those things. We're passing in F2, so we're passing in F2 and giving it a name called A, so we can access A's methods. And what we need to do is just implement this thing. How do we implement this thing in our code here? And like basically we just need to divide this into two parts. The top, the numerator, and then the bottom, the denominator. And then whatever you get as a result for that, however you get those values, we can just update the value of temp and make its new, make this value, which I think was the numerator, make that equal to however you calculated this, make the denominator equal to however you calculated this, and we're done. And we just return temp. So there's just a little bit of a task in here for you in the middle. But the important part from today, going forward, is taking the concrete, taking the very abstract concept, and then finding some concrete examples to work through, and using that to guide us writing our code. If we are just going directly into coding and skipping any of these prior steps, we're going to have problems because it's really hard to think abstractly. It works a lot easier to think things through concretely and then work towards abstract. If you can do this right away, good, great for you. I'm proud of you, and it's a challenge to do, and I can probably do it right away, but I've also done this a lot and I've had a lot of practice, so I might be able to jump right into it, but it would be a lot easier for me. If I got stuck, I'd be thinking back about the concrete and thinking about, okay, how would this work in real life? Okay, let me see how I can translate that into code. That's just what you do when you're writing code. Okay, so that's my video on that. I hope that it was helpful.